Good morning, ladies and gentlemen. This is section 2.7 and 2.8 in Algebra 2. And today we're going to start by looking at data sets and finding a good model that would hold true for all the data points. If I look at pressure and volume, I notice that as pressure is increasing, volume is decreasing. And so since they are offset, one is growing while the other is shrinking and vice versa, I know that this is an inverse relationship. So I can say volume varies inversely with pressure. Now at this point I don't know what power is on pressure. It could be the power of 1, could be the power of 2, power of 3, and I need to check that. But I notice that my points are not that different from each other in size. So I'm going to estimate that it's the power of 1. As I plug in 83 for volume and 20 for pressure, we're going to check out this first point and see what the value for K is. When I multiply both sides by 20, I get 1660. Then I'm going to move on to my second point. And when I plug in 55 for volume and 30 for pressure, I end up with K equaling 1650. While it's pretty close, and at this point I can see I'm not going to find a better model. This is going to be the closest model that fits. If you find K for all of these points, they're going to be very close to this value, but not quite all exactly the same. And that's because that's a lot of times what happens in real world situations. We can get close and find a model of best fit, but it's not an exact model when we deal with real world data. So for this class, we're always going to use the K, once we found the model, from the second point. So I'll use this value of K, and my equation will be volume varies inversely with K equal to 1650 to pressure. Let's try another one. If I look at this data set, T is increasing as D is increasing. That means that this model should be direct. So I'm going to start off with D equals K times T and see if my first two data points come out with a K that's pretty close. I'll plug in 0.6 for K and 1 for T, and that means that K is 0.6 when I look at my first point. Now let's look at my second point and see if my K is pretty close to that. When D is 2.4 and K is 2, I get a value of 1.2, and those values are not at all close. And so we're going to have to reevaluate our model. I'm going to erase this work, and let's see what happens when we give T the power of 2. So I'm going to come over here, make T to the power of 2, and see if that will give me a closer relationship. I want to see things that are all about that same value. So when D is 0.6, I have 1 squared. Again, K is 0.6. And I want to be pretty close to that value on each and every point. Let's see, when D is 2.4 and T is 2, I'm going to get 2 squared is 4. And when I divide that on both sides, I get 0.6 again. So now I'm getting pretty close. Now I can tell that this, and if I check these points, it'll be pretty close for each and every one. It might not be exactly the same for each point, but I'm going to be pretty close. So now I think I've found my K value, and I'm going to plug it back into my function, and I get this as my function. D varies directly to T squared by a constant of 0.6. Now if you graphed these points right here, they would graph in some parabolic pattern. So that's another way to double check yourself. If I have a parabolic pattern over here, I know that my function is probably a D squared or a X squared. Here, if I graphed these, I would see something that would show me an inverse pattern. As X is getting bigger, Y is getting smaller. I would see something like that. It would show me I need to check for an inverse pattern. All right, for tomorrow, I would like you to try these. Figure out if it's inverse or direct by whether D is increasing as I is increasing, or D is increasing as I is decreasing, whichever it is. Try to figure out if it's either inverse or direct, and then find your value of K. Then I'm going to go ahead and finish 2.8. In 2.8, we're going to look at the converse of the fundamental theorem of variation. If we multiply every x value by c, and the result is multiplying the corresponding y value by c to the n, y is going to vary directly as the nth power of x. That just means we're going to go in the opposite operation. If you remember in this chapter, we've been saying, hey, for an equation like this, if we multiply x by c, that implies that y gets multiplied by c to the n. Now we're going in the opposite direction and saying, hey, if this is happening, then I know that this is happening. And so if we look at this data set right here, and we want to find the equation, we want to see how W is changing based on our inputs of M. So M is increasing as W is increasing. So I've made this estimation that we have in a direct relationship. If we graphed these points, and let's go ahead and graph them on your calculator, go ahead and hit stat. Because before we get going too much further, I want us to make sure we understand how to tell whether the power on W is 1, 2, or 3. If we hit stat, and then enter, you'll see list 1, list 2. Your x values will go in list 1. So plug these in list 1, and your y values, or your dependent variable, will go in list 2. So in list 1, you'll plug in 1, 2, 3, 4, 5, 6. Over here in list 2, you'll plug in 27, 53, 80, 107, 133, and 160. And now you need to change your window so that you can see this graph. I'll make my x min a -1 and my x max about 10. That'll allow me to see all 6 points. For my y value, I'll make my y minimum 0. And my y maximum, how about 165? That way I can see all points. And now you should have all your points plugged in and your window set. Hit second y equals to bring up your scatter plot. You'll hit enter, enter to turn it on, and then hit graph. And hopefully you see something like this. So it's kind of hard to tell yet whether it's direct or, whether it's a power of 1 or a power of 2. But to me, the pattern I see on my calculator looks pretty linear. Hopefully you agree that this looks like a straight line to me, not like a curved parabolic function. So I'm going to check this right here to see if I get the same value of k each time. And when I plug in the value of 1, I'll do that over here. When m is 1, k or w is 27, and k equals approximately 0.037. When m is 2, k is 53, and 2 divided by 53 is again, gives me a k value of 0.037. So now that I got the same value of k for both points, I have found my pattern, and I always use this point to find k. We're just going to use that second point when we have choices to choose from there. And so we're going to plug in k, and now I can say m varies directly by 0.037 to w to the power of 1. Now, I know I went through that process of graphing with your list 1, list 2 pretty fast. So I'm going to go to the next slide. And this right here gives you the operations to graph. You're going to hit stat, hit enter, plug in your x or your independent values for list 1, plug in your y or your dependent values for list 2, and then this operation will get you to your scatter plot. You want to make sure it's turned on. Make sure your window matches your data, then hit graph. Once we get a little bit farther, I'll show you how to also find those lines of linear regression and quadratic regression. You can find your exact values of k by following this right here. And we'll talk about that a little more in class. I will see you tomorrow.